So till last class, we were discussing about what is an atom, how an atom is charged or not charged, how an atom is neutral, what are the subatomic particles, what brings in the charge, what happens when there is a, what brings in the charge, is it the protons or the electrons, what happens when an electron goes away. Yeah, so we have discussed all of that in the last class, right? Right?
Huh.
In today's class, we are going to revise through the current and charges and everything. Why are we talking about charge in a chapter of electricity? That's because the charge that we just talked about in the last class, when there's a continuous flow of that charge, that is what is getting converted into a current. Okay, when there's a continuous flow of the charge. Now, what do I mean by the charge? What charge? Positive or negative?
Negative.
So which means what is actually flowing? Which subatomic particle is actually flowing?
Electrons.
It is the electrons. Very good. All right. So before we proceed with this, there are certain pictures that certain symbols that we need to know before we get into the electricity chapter fully. All right. Certain symbols, I mean, can you see on your screen? There are certain symbols like there is a cell, then here. You see there is a cell here. Yeah. What is the symbol of the cell looking like?
Big body line and a choti line.
One big line and one small line. The bigger line is what charge? What is shown there on the bigger line?
Negative.
Bigger line.
Positive.
It's always positive. And the smaller line is always negative. All right. So if you show charge on one of them, it's the bigger is always positive. Then what is this symbol for?
Switch.
That's a switch. What position is the switch on right now?
Open
on
switch.
And off? On or off? Open means on or off?
Off.
Open means?
Off.
On.
Both of you are saying two different things, I think.
मैं off बोल रहा हूँ.
Abhimanyu is saying off. What about Aniket?
On.
When the switch is open, that means it is off, which means the current will not flow. Okay, Aniket?
Okay.
This open symbol, open means the circuit is not closed. Okay, so the current is not able to, so the current was flowing, but suddenly at a point it could not flow further. So the current is not able to move ahead. So what it means, the switch is open, so the switch is off. The switch is closed when the switch is on. Clear?
Yeah.
Okay. Then what is the symbol?
Bulb.
Lamp.
A bulb.
कोई भी component.
It's a bulb. All right. Okay. Then I'll come to these two later. What about this one? What is this? A?
Measures the current.
Ammeter. So what is ammeter? Measures the current. Okay. What is this symbol for?
Resistor.
Resistor. Then this is also resistor, but it has an arrow. What does it mean?
Variable resistor.
It's a variable resistor. Okay. What about this one?
Voltmeter.
Voltmeter. What is the job of voltmeter?
Calculate voltage.
Calculate voltage.
Measure
Now,
voltage.
It measures the voltage, not calculate, measures the voltage. Okay. So these figures I left in between. Okay. Now these two symbols I left in between. What are these two symbols? Now, Aniket, for you, this is a diode. These are two diodes. One has two arrows on it. Both are diodes, but the second one is a light emitting diode. I just want to quickly discuss what a diode is actually. Okay. So if I have a circuit and in my circuit I put a diode, then what will happen? Okay, so look at the symbol of diode. Does it look something like this? Aisa hai na? The symbol looks like this, right? Now the diode speciality is if you put it in a circuit, like in this here, do you see there's a diode kept? What will happen? So the current is supposed flowing in this manner. Suppose the current was flowing in this manner. So if the current, and in this circuit, this diode is going to allow the current to flow. But if I just turn the diode around like this, I just turned the diode around like this, what happens?
Current flow nahi hoga.
Current will not flow. That is the speciality of diode. If you flip it, it won't allow the current to flow. It breaks the circuit. Okay. So how do we remember? Arrow should match the arrow. If my arrow of current and the diode's arrow are not matching, then I will say there's like a barrier in front. then I would say that the current is not going to flow. Okay, this is understood, right? What is a diode, right?
But
Okay.
what does it exactly do?
It is used to either stop. It's like a break-in circuit, right? It has other features also, but if you flip it, you will you don't want the current to pass, you flip it. Okay, that's a diode.
Yeah.
Okay. So you know, the diode is usually to like, if you can see here, there's one statement about diodes. So you would damage a portable radio. There's a portable radio which is connected, and you would damage a portable radio if you put the current, if you put the battery other way around. So this is going to damage my radio. So what we do is, before that radio, we put a diode in the circuit. So just in case, by mistake, I put the battery other way around, this diode is actually going to protect my radio. If it is other way around, it will not allow, the diode will not allow the current only. Even if the battery is other way around, my diode will stop the current to flow. Only if it is correctly placed, then the diode will allow. So this way, my diode is actually protecting the radio. Okay. Did you get the point?
Yeah.
Now we move to the next point. What about this fuse here?
जब overheat हो जाता है circuit तभी break करता है और फिर
So
electricity
when will
pass
the
होती
circuit
है.
get overheated? When will the circuit be overheated?
जब ज़्यादा variable resistor में ज़्यादा resistance हो.
Not really. Not really. Not
When
really.
When there's too much charge.
Flow of electrons.
Current. And there's a high current. With high current, there is high heat. There is heat produced. Okay. And when there is heat produced, then what will happen? The circuit will melt. It will break. The circuit, the fuse will melt, because fuse is designed only to melt if there is little extra heat. So it will be okay if there is certain amount of heat, but suppose the current was supposed to be 5 amperes, the current became 7 amperes. Then what happens? There is a fuse which is allowing at 5 amperes, the amount of heat that is being created because of that 5 amperes, this fuse is allowing. But the moment it becomes 7 amperes, what will happen? There is some extra heat. So the fuse will sense that extra heat and it will melt. So it is more like a protector again. So it is going to protect, it will break the circuit, it is going to protect my circuit, rest of the instruments. Because it is possible that if so much of current is flowing, then it can damage my phone, or it can damage my laptop, or it can damage the fan in the house, whatever the current is reaching to, whichever place it is reaching to, it can damage. So what is the fuse doing to us? It is protecting. It is a protector. Clear? So how does it do that? It is designed, how will you write it? It is designed to melt and therefore break the circuit. Okay, got the point? It is designed to melt and break the circuit. So, but will it melt at every point? No. It will melt only, so every fuse has a rating. So for that rating, it will be perfectly working. But if the rating is something, say 5 amperes, but the current flowing through it is 7 amperes, then the fuse is going to melt, because it'll say, no, I am not designed for this 7 amperes, I'm designed for 5 amperes. I hope my point is clear.
Yeah.
Now we come to the next point. We have understood all the symbols, then the electric current. So an electric current is a flow of charge. When an electric torch is on, then what will happen? Flow of charge will happen. What charge? It is a flow of electrons. Okay, because what is the charge in every electron? Every electron is negatively charged. Okay. Now what happens? How does this flow happen? So what is the wire made up of? Can anybody tell me?
Copper.
Copper. Copper is a metal or a non-metal?
Metal.
And metals have a lot of free ions, free electrons. What does a metal have?
Free ions.
Free electrons. Free electrons are going to metal, because any metal has free electrons. These free electrons, the moment you switch on right? These free electrons will start moving, and they are the ones which are causing the current to flow. I hope we are clear.
Yeah.
This current will not flow if in place of wire I put a wood. It will not flow. Why?
बस free electrons नहीं होते क्योंकि
Because free electrons नहीं होते, correct. So this part is also clear. Any confusion? No confusion? Okay. Now, all right. Okay. Now there's another point. Now the point is, what if there can be some electrons, only few electrons passing through the current, passing through the wire, or there can be a large amount of electrons passing through the wire. Okay. So when do I say it's large current and when do I say it's a small current?
जब amperes में ammeter में ज़्यादा reading आती है तब.
Or when do I know? When do I know? Okay. So I'll say when in terms of electrons, if I want to answer the question, in terms of electrons. So when in 1 second of time, in just 1 second, there are say 10,000 electrons passing. Okay. And another wire, in 1 second, there are 1 lakh electrons passing through it. Which one will have more current?
1 lakh electrons.
1 lakh, because in 1 second, 1 lakh electrons are passing. So I know that this is going to be a large current. Okay. So for this, we have a formula. And what is the formula? I made you write. Please keep a note of this formula. Charge. So like I said, the current is the number of electrons passing in 1 second. All right. So my formula becomes I is equal to Q upon T. I is equal to Q upon T. I hope this is clear. Okay. Now what is this I? I is current, right? What is the unit for current? It's amperes. What is this Q? Q is charge. What is the unit for charge? It is coulombs. What is this? This is time, which is time, and the unit is seconds. I hope we are clear now, right? Okay. So you have to make a note of this because we'll be using this in a lot of formulas, all right? So this part is clear about the relationship between current and charge, clear? Eh?
Yeah.
Then comes potential difference and resistance. Okay. Now, what do we use to measure current?
Ammeter.
Ammeter. Okay. So an ammeter measures the current through the torch bulb. Like if you're measuring, if you see this circuit here. So what all things do we see? There is a cell. There is an ammeter. There's a bulb, right? Cell.
Battery हुई ना क्योंकि 2 सेल है.
Battery with them, right? Battery, okay. Then there's an ammeter, there is a bulb, and there's a voltmeter, right? So this ammeter is going to measure what?
Current.
The current. And this voltmeter is measuring what?
Voltage.
Voltage. And how do I connect the ammeter?
In series.
Always in series. How do we connect the voltmeter?
Parallel.
Perfect. Okay. So this we know. Now what is voltmeter measuring here? You said it is measuring the voltage, right? Or it is measuring the potential difference across the bulb, right? This is now what is this potential difference? Okay. Now potential difference is something like, I'm just giving you a hypothetical situation. There is one electron which has to move from one place to another place. What is it? There's an electron which has to move from one place to another, which means it has to make the current, right? Flow. But now the electron needs some energy to move. No? The electron has no energy, then how will it move? So that wire that we were talking about earlier, the copper wire, it had free electrons, but were they moving on their own?
No.
Only if you connect the battery, they start moving, right? So what are you giving them? You're giving them energy. So it's like a push. So you're pushing, right? So this potential difference is what you provided. This voltage is what you provided, right? Through that battery, what did you provide? You provided a voltage. So what is this potential difference? This potential difference is the energy which is transferred to the bulb or work done on each charge that passes through it. So every charge has to move from one place to another. So there's some work which needs to be done. Every electron has to move from one place to another. So there's some work is being done. That is the potential difference. I hope this point is clear. Correct? Okay. Now, I've already asked you, what is the unit for potential difference? And how do you represent it?
V, voltage.
It is V, yani
Volts.
volts. Okay. Voltage is the word, and volts is the unit for measuring it. Okay. So again, like we had a formula there, we have another formula. Potential difference across a component is energy transferred upon the charge. E upon Q. Make a note. E upon Q. E upon Q. Okay. The other word that comes to us now is the resistance. Okay. Now, what is this resistance now? What is this resistance? So I always say, so for charge, you understood what is charge, right? Charge is nothing but one electron, which are freely sitting here and there. And that is when they start moving, it becomes current, right? And then what is potential difference or voltage? It is nothing but the energy which is needed by every electron to move ahead. If you give less energy, it'll move less. If you give a lot of energy, it'll move more, right? It'll move so much that it can produce a lot of heat and it can cause damage, right? Now, what is this resistance? So imagine resistance as something like, Aniket, you're concentrating here?
Yeah.
Yeah, okay. So imagine resistance as something as, you want to open a door, right? On one side it's Aniket, on the other side it's Abhimanyu, okay? Now Aniket is trying to open, but Abhimanyu is not allowing him to open. So what is Abhimanyu trying to do? Abhimanyu is trying to resist you, right? So that exactly the same thing is, the voltage is trying that I am giving it more energy, electrons have to flow. But what is resistance doing?
Stopping it.
Is stopping it. All right. So you're the voltage and Abhimanyu is
Resistor.
resistance. Okay. So you are giving him more energy, but the door, which is the electron, is not able to move because Abhimanyu is resisting it. Okay. Now, if Abhimanyu changes into a copper wire, so will the resistance be very high or low?
High.
It'll be resistance.
High.
Think about resistance.
Oh, resistance will be low, sorry.
Resistance will be low. So because Abhimanyu becomes a good conductor, right? Now, if Abhimanyu changes into a wood, then what will happen? Then he'll resist more because now there are free electrons are gone. So what will happen? He becomes a very high resistor. Okay. So what is resistance? Resistance is, the word itself is telling you what is resistance. Atoms resist the passage of electrons. Atoms resisting the passage of electrons, correct? So whenever you're studying this chapter, to go through each and every statement written. When you're preparing for this test next week, make sure to study every statement. I can ask anything from anywhere. And whatever I'm going to prepare is from this textbook only, so that I want to check how much you've read from the textbook. Every word by word, each and every numerical. Okay. All right. Okay. So this first test that I will be taking on this topic will be from the book. So you need to just read your book thoroughly. No questions from anywhere else. You'd see all the textbook questions I'm going to ask from there only. And in between the paragraphs. So read through everything perfectly. If you don't understand, click pictures, put it on the group that I didn't understand this word or this statement or this question. Okay. I'll help you out before the class. Okay. Right. Okay. Now we come to, so then of course, like we have a formula for current, we had a formula for voltage. Now we have a formula for resistance. And what is that resistance? Resistance is potential difference upon current. Okay. Potential difference upon current. Potential difference kya hai? That is voltage. And what is current? It is I. Current, right? Voltage upon current. And if you can rearrange it in the way you want to, like If I want to find out I will make it V upon R. If I want to find out V, I can do it as I into R, right? So few things that I need to understand. What is the relationship between I and R? I is on one side and R is in the denominator. So they are inversely proportional. Okay. And what is the relationship between V and I? V and I both are in the numerator, so they are directly proportional. Okay. So these are few things that you need to understand here. All right. Any confusion? Nothing? Okay. What is the symbol for resistance? It is
R.
R.
Coulomb.
Ohms. Symbol for resistance is R, but the unit symbol is ohms, right? It's called as OHMS, or you will see this omega symbol. Okay. So I think the basics of all of them is clear to us till now. Then we move to the next. What if I draw a graph between the current and resistance? Okay, so that is something you will see here. What if I draw a graph between current and resistance? What do you see on the x-axis here on the graph on the side and the y-axis?
Which axis?
Y current, X potential difference.
Okay. Potential difference. Say it again, Abhimanyu.
X potential difference and Y current.
X is potential difference and Y is current. So you always know that what do you put on the x-axis always? You put the IV. What is IV? Independent variable. Independent variable. Always on the x-axis. What do you put on the y-axis? Vertical axis, you always put the dV. What is dV? The dependent variable, right? So more the voltage, more the current. They are directly proportional. That's what we learned. So more the voltage, more the current. Now, if we do this experimentally, okay, what are we doing doing experimentally? We are going to make a circuit where we will understand what is this relationship, okay? So have a look here. This is your circuit. You made a circuit. In that circuit, you have a switch, you have battery, you have a variable resistor. Why variable resistor? Because you want to vary and check ki kya hota hai, how it changes, how the current will change. So check the rating here, the values here, and voltage across a particular wire. Okay. So what are we doing? We gave a voltage, but what are we putting here? We are just putting a variable resistor. Actually, we are measuring the resistance across this, but this will help us to increase or decrease the current. Okay, this is going to help us in increasing or decreasing the current. Okay, because voltage is fixed. Otherwise, how will you change the voltage? You can't change it. So you change it through the variable resistor by increasing or decreasing. So what happens if you change this? The current will change, and they are in series. This ammeter and this one is in series and this one is in series. So they will have a same current, whatever is there. Because of the changes in this, whatever is there will be here, because they are in series.
Current same.
Current same is same in series, right? Okay. Now, next. Okay. After this is understood, then we started figuring out that what happens if I increase the potential difference. So earlier the potential difference that was kept was just 0.5. So what you saw was, okay, there's a 0.5 ka current. Then you increase the potential difference to 1. The current भी 1 हो गया. Then you increase it to 1.5. You saw ये भी उतना ही हो गया, right? 2, ये भी उतना ही हो गया. 2 मतलब it's not 2 here, it is 0.2, but what I'm trying to say is this is increasing, so this is also increasing. This is increasing, this is also increasing. And if you actually see, you see this becomes a linear relationship. How? Because between 0.5 and 0. If you divide it, if you find the gradient, okay? How do you find the gradient? Change in y upon change in x, right? So change in y upon change in x, how do you see what happens? What do you see?
Change in y 0.05.
That gives you the gradient. So you find out the value of m. वो कितना आ रहा है? Can you tell me? Change in y will be 0.05 and change in x is how much?
0.05 upon
0.5.
0.5.
What about the next case? 1 and 0.01? 1 and 0. So yeah, this one is 0. Change in y is 0.10 upon 1. Aniket, you're getting this, right?
Yeah.
You understand gradient, right?
Yeah.
So let's figure out iska answer. What is the answer for this one? How much do you get?
0.1.
So it's 0.05 divided by 0.5, which is 0.1.
0.00.
And what about 0.1, right? What about 0.1? This is also 0.1. And if you see, it's the case with all throughout. Same thing, right? So what do we understand from this? We understand that the gradient is same, 0.1. And what is that telling us? The grade, see, what did we just do? Change in y was I and change in x was v. And we know v is equal to IR, right? So if v upon I is R, I upon v will be 1 upon R. That's what we are getting. By finding the gradient, and if I reciprocate it, I will get the value of R just by looking at the graph. Did you get this point? So I hope this point is also clear to everybody. Aniket, if there's any question, please ask.
Okay.
No question, no doubts?
No.
No, very good. Okay. Make sure to read the key pointers, okay? Because that tells us everything about whatever we read in that particular article, okay? Key points, it says potential difference across the component V is energy upon Q, right? R is equal to V upon I. Ohm's law. Now this is the statement. This one is the statement for Ohm's law, and this is the mathematical formula for Ohm's law. What does it tell us? Potential difference is directly proportional to the current. But there are two things that you need to maintain. What are the two things that you need to maintain? One, that the temperature should not change and the pressure should not change. Temperature and pressure should not. ऐसा नहीं कि room का temperature आपने change कर दिया. You can't change it, okay? So what does Ohm's law tell us? You have to write about temperature. But children, what happens when they write the statement for Ohm's law? They talk about resistance, current, voltage, but they forget about temperature. Because if you change the conditions, then there will be a change in the resistance. Okay, so you have to make sure that the pressure temperature conditions, there's no change in that. I hope this part is clear.
Yeah.
Now, one question for you. Tell me, what if I get I made a VI graph and I get a graph like this. This is A. And I get another, in a third question, I get a graph like this. What can I tell about the resistance here in the three cases?
A की रेजिस्टेंस स्टेबल है, चेंज नहीं हो रही. B की रेजिस्टेंस डिफरेंट है और C की B की बहुत ज़्यादा है, B की नॉर्मल है और C की बहुत कम है.
So you mean to say, ध्यान से सोचना, resistance या सोचना.
If B has more current, so the resistance is less in B.
Yes, because
more
what
in
were
C.
we getting here? We were getting 1 upon R. Here we get 1 upon r. Here we get 1 upon r. Now you have to be very careful to see. Sometimes they will try to confuse you. They will do V here and I here. In that case, what you get is resistance. But in this particular graph, what are we getting? I is here and V is here. So when you found out the gradient, you got change in Y as I and change in X as V, right? So it's not V upon I, it's I upon V, which means the gradient is 1 upon R. इसको जब रेसिप्रोकेट करोगे तो आंसर मिलेगा. अगर ये ग्राफ देता हमें, if we would have got this graph, then we would straight away gotten the answer for V, for R. But this graph, you get 1 upon R, you have to further do a calculation to get R. So when you have, suppose I have 10 ohms, so 1 upon 10, and I have 20 ohms, 1 upon 20. This will be lower than this, jabki this is bigger than this. So always remember, you have to be very careful. They play a lot with the VI graphs. They try to confuse you with various possibilities. You have to really see that what is here, this is current, and what is here, this is voltage. What you get in as a slope here is the gradient 1 upon R. The gradient becomes 1 upon R. Did you get my point?
Yeah.
So this one has low resistance and this one has high resistance because it's IV graph and we are getting the gradient as 1 upon R. Had it been this graph and I had 3 lines like this, A, B, and C, then in this case, A is highest resistance. You all agree?
Yeah.
Clear now? This is most important concept in this particular topic, okay? From circuit, series and parallel circuits, you are aware of already whatever is there, right? That part is clear to us. I have made that video already. Okay. Now, certain important. So what if I use a few important components that we are supposed to use? Okay. What is the formula for resistance? Can you tell me quickly? Formula
potential difference upon current.
Upon current. Okay. Have you ever touched a bulb by any chance? A bulb, a glowing bulb. How does it feel? Is it hot or is it cool?
Hot.
Why does it become so hot?
Because of the current.
Flow of current.
But why doesn't everything has current? Why doesn't everything become so hot like the bulb? Bulb becomes
glass hota hai.
Or is it just because the glass? Ideally, glasses do not get heated up, but that gets heated up quite a bit.
Is it because of the light?
It's because of the light. What is in the light? That is
thermal energy.
Thermal energy. Okay, heating up is because thermal energy is there, but where is that thermal energy coming from? What is it?
From the resistance.
Because of the resistance, yes. So higher the resistance. Now imagine karo Aniket, again, you are the voltage, hai na? Now Abhimanyu is the resistance. So if Abhimanyu is trying to hold the door, you are trying to push the door, what will happen to you? Abhimanyu is not putting in any effort. He is just holding the door. Will you need to put any effort?
If I'm pushing the door.
If you're pushing the door and Abhimanyu is not resisting much, then what will happen?
Yeah.
The door will easily
not,
open.
Yeah.
Then you will, if he's not, then will you put more energy or less energy?
Less energy.
Less energy. Now Abhimanyu increased his resistance. He's increasing his resistance. And he's increased his resistance in such a way that Abhimanyu and his dad is also pushing the door now. Okay? Then what will happen?
I need to put more energy.
You need to put in more energy,
Yeah.
right? You will be putting in more energy. Now, more, in this case, you're putting even more because now you have to resist not just Abhimanyu, but his dad also, right? Because both of them are resisting. So you have to push through both of them, right? पसीने आ जाएंगे, गर्मी लगेगी, पसीना निकल जाएगा, रहेगा, होगा ना, right? Why will that happen? Lot of thermal heat will be, and you will be, all pasina ho jaoge because you're putting in a lot of energy, right? Now, something similar happens here. यहाँ पसीना नहीं निकलेगा, but the only thing that will happen here is that you are, he is resisting us. He is resisting the current, right? So what will happen? You are getting heated up because you're trying to push through him. So in this case, just one difference is that you aren't getting heated up. Abhimanyu is getting heated up. The resistance is getting heated up. Okay, wherever that resistance is. So in that bulb that we're talking about, have you seen there's a filament in the bulb?
Yeah.
Something like this, right? That filament is tungsten. And if you Google search what is tungsten, you will see that tungsten is one of the elements which has,
Thermometer में भी use होता है.
that's mercury. This is
Tungsten
tungsten.
नहीं है.
नहीं.
It has a lot of
Oh.
resistance.
It has a very, very high resistance, which means it is not going to allow the current to flow through it, right? So because of that, but Aniket is pushing, or Abhimanyu is stopping. Aniket is pushing, Abhimanyu is stopping. So there, Abhimanyu is getting heated up because he's trying very hard to stop, but Aniket is not stopping. So what happened? This starts, because of the resistance, this starts glowing. And that's how bulb glows, because of so much of heat. Now, something similar happens in the oven. Oven mein dekha kab? Have you seen? Oven mein there is this wire, thick wire, metal wire, right? What that does, have you seen it becomes red? When you switch on the current, it becomes red, and that's how you're able to bake a cake because of that heat in the oven. Same thing happens here. Aniket is pushing, but Abhimanyu, who's the resistance, is stopping it. And it has so high resistance that Abhimanyu has so high resistance that it is trying to stop very hard. Are you getting my point?
Yeah.
So Abhimanyu is red now and is radiating heat. So red that it is radiating heat. And that's how it is working. So you understood the point? Right?
Yeah.
Now this point is very, very clear. Next. So one thing that is clear to you now, that if there is a lot of heat, then what will happen?
The bulb will start to glow or garam hoga.
And if there's a high current, high resistance, then it will try to resist. So what will be produced? Heat will be produced. Clear? A lot of heat will be produced. Okay. Now we come to certain pointers, other pointers. Okay. All right. Now we come to a diode. So diode mein kya hota hai? If you see, what did I tell you? Diode has a certain figure, right? So what does it do? In one direction, it allows the current to flow, but in the other direction, it does not allow the current to flow. Right?
Stops the backflow.
So how do we say it? So we have a particular way of saying it. In diode, the forward resistance is low because it is forward in this direction. It is allowing the current. So what do we say? The forward resistance is low, but if you just reverse it, then the reverse resistance is high. Clear?
Okay.
Okay. And how does the graph look like for a diode? We'll see that now. You see a figure here?
हाँ.
Figure 3 shows a current and potential difference of a difference graph of a diode. The current through the diode flows in one direction only, and that is called the forward. So if you see, the current starts developing only here, which means before that, what happened is there is no current. Why is there no current? Even though there's voltage, there's no current. In the forward direction, the line curves towards the y-axis. So the
आपका कॉल आ रहा है.
So in the forward direction, the line curves towards the y-axis. So the current is not directly proportional to the potential difference. The resistance changes as the current changes. Okay. That part is clear. The resistance changes as the current changes. What happens in the reverse direction? These are the reasoning why this happens. Okay. In the reverse direction, the current is virtually zero. That we know. There's no current that is able to. So the diode's resistance in the reverse direction is very, very high. When there's no current, that means the resistance becomes suddenly very high. Okay, that is the reason why. So the question can be that why does a diode, how does a diode behave? What is the graph of the diode? And why does it behave in such a way? In forward direction, what happens? In reverse direction, what happens? Okay, so this part is clear?
Yeah.
What happens in a light emitting diode? In a diode that emits light when a current passes through it in the forward direction. So just that, it's this LED is just an indicator that the current is flowing. That's all. So light emitting diode is nothing but a diode only, just that it gives you an indication that there is some light which is there. There is some current which is there in the circuit. So obviously, which direction it will, forward or reverse? Which direction the light will glow?
Forward.
Has to be forward, because if it is reversed, no current, which means there's no indication only. What is this indication for? This indication is for the current only, right? And if it is in the reverse direction, then of course there's no current. Clear? Then comes another component, which is thermistor. Okay, thermistor. Therm means
Heat.
Okay, so it has something to do with heat. So a thermistor and a light dependent resistors, they are used for sensors. We've seen many sensors in many places. So they will sense something, right? So thermistor is going to sense the temperature. Light dependent resistor will sense the light. Okay, so a thermistor is a temperature dependent resistor. Therm plus resistor ka resistor. So therm, which is heat, resistor ka resistor. So it is a temperature dependent resistor. And most importantly, which means it is going to change resistance. Okay, which means it is going to change resistance. How does it change? Its resistance decreases if the temperature increases, and increases if the temperature decreases. Very, very important point here. Temperature is increased, then the resistance is decreased. This is temperature. If the temperature is reduced, then the resistance is increased. So it will behave it will allow the current only if the temperature is high. Such resistors, can I say that they will follow Ohm's law? Think again. Ohm's law, there was one condition. Is it an ohmic? Because this is now dependent on temperature. It will, no matter what voltage you're giving it, it is dependent on temperature. So it is not following the Ohm's law perfectly. Got my point? So such a resistor is a non-ohmic resistor. Non-ohmic, because it is not going to follow the Ohm's law properly. This is a special kind. Is my point clear? Then comes the resistance of a light dependent resistor. Again, what is it used for? Sensor. As a sensor. What is the work? Again, a resistor, but it is dependent on light. Decreases, its resistance is decreasing when light intensity is increased. So more the light, less is the resistance. Clear?
Yeah.
Clear? Easy? You will get some questions based on this, okay? Then comes your next point. One more thing, one more graph. That's all for today. Okay, so using a current potential difference graph for a filament lamp. Do you see this? There's this graph here, current potential difference graph for a filament lamp. Okay. What do you see here? The line curves away from the y-axis. Curves away from the y. So there's a curve now. It's not like a straight line, right? That is low voltage filament lamp. Okay. In this, we are talking about low voltage filament lamp. Okay. So the current is not directly proportional to the potential difference. That the filament lamp is non-ohmic. This is also non-ohmic type because had it been ohmic type, then it should have been like this straight line. It's curving away, which means when you see curves, that means they're not following the Ohm's law. Diode doesn't follow Ohm's law. This particular filament lamp, which we're talking about, will not follow Ohm's law. Okay. Then diode will not follow Ohm's law because again there is a curve. These resistors that we talked about, thermistor and the light LDR, the light dependent resistors, they will also not follow Ohm's law. So they are non-ohmic resistors, right? Okay. Because what you see in the graph, there's a curve. There should not be a curve in ohmic conductors, resistors. Okay. So here you see, first part is clear, that you see that there's a the current is not directly proportional to the potential difference, and the filament is non-ohmic conductor. Clear? Then comes equation for the resistance of an appliances. You know, the resistance is equal to voltage upon current, right? Right. Now we will interpret this graph. The resistance increases as the current increases for some point. Resistance increases as the current increases. The resistance increases as the current is. So the resistance of the filament increases as the filament temperature increases. The atoms in the filament, they are directly proportional. So more the current, more the resistance. More the current, more the resistance. So in fact, more current is giving in more resistance. So, and then the reason they are speaking about the reason here, it says the atoms in the metal filament vibrate more. You know that when the temperature increases, kinetic energy increases, so the atoms will vibrate at their position. So they resist the passage of electrons through the filament more. The resistance of any metal increases as the temperature increases. That we have already discussed before, that resistance increases as the temperature is going to increase in these non-ohmic kind of resistances. Okay. Reversing the potential difference reverses the current and makes no difference to the shape of the curve, hence which happens in a diode. If you reverse the other side, it doesn't do anything, right? So the current becomes zero, but here it doesn't matter, the curve remains the same like this. Clear one? Okay, that's all. Okay, now the revision